Okay, so we're about to add a couple of characters to this story here. We're going to add hydrogen ions. You see the H's, and then we have oxygen over here on complex number 4 at the very end. And then we also have our NADH and FADH2, which came from glycolysis and from the Krebs cycle. So let's follow NADH with those high energy electrons. NADH is going to come drop off those electrons, and it's going to drop the hydrogen, and then it's going to become NAD. Then it will go back to the Krebs cycle or to glycolysis and pick up more high energy electrons. So let's look at these electrons as they go down the energy gradient. So it's helpful to think of this as a slide. Think of a child at the top of a slide, and as they're sliding down, every instance that they slide down, they're losing height. As they lose height, they lose energy until they reach the very bottom where they hit a grounded state where they're stable. So a child at the very top is high energy, and at the bottom is grounded, from excited to grounded. So at this point, our electrons are excited, and they're going to go down the electron transport chain slide to meet up with oxygen at the very bottom of it. And every step of the way, as these electrons move, they get handed off from protein to protein, complex number 2 now. Now you'll also notice that hydrogen ions are getting pushed up into the intermembrane space from the matrix. So they're going from the matrix to the intermembrane space. Now these electrons are going to get passed on again to another protein, and then more hydrogen ions get pushed up. They're at the final stage now, at complex number 4. Now at this point, they're at the bottom of the slide, so they're actually way more, or they're at a less energy state than they were in the very beginning. So they're more stable, these electrons are now. And so they're going to meet up with oxygen. Oxygen is the final electron acceptor. It's like a magnet that attracts the electrons from complex number 1 all the way to complex number 4. Without oxygen, without that magnet, these electrons do not move down the electron transport chain. They stop moving, and if they stop moving, then they stop pumping hydrogen ions into the inner membrane space. And as you see, in fact, let me take a step back. Notice how these electrons, as they move down, they combine with oxygen and 2 hydrogens to make our final waste product of water, H2O. Okay, now again, notice how the hydrogen ions are pumped up into the inner membrane space. Now this is important, and we'll get to that in just a second, but follow me now with FADH2. So as we pick up with FADH2, we're going to notice the same pattern, except that the electrons are going to be dropped off in complex number 2. Complex number 2 is a lower energy state than complex number 1 was. So the electrons that are in FADH2 are actually a lower energy state than the ones that were in NADH. The amount of energy that's in the electrons in FADH2 are about a third the amount that are in NADH. Nevertheless, the electrons get dropped off, and now they're on their way, that electron transport chain slide, if you will, and going into complex number 3, and as they leave, they're pumping hydrogen ions into the intermembrane space. And then as they lose more energy and they become more stable and they get into a grounded state, they will now join up with that final electron acceptor, oxygen, and they will combine with 2 hydrogens to make the waste product, water.